All right, so welcome to the second screencast for Chapter 2. In this screencast, we're going to talk about how economists build models to help us understand the real world, and something called a ceteris paribus assumption. Economists use models to help us understand the complexity of the real world. The real world is a complex place. There's a lot of interactions. It's very complicated, and so models help us simplify things so that we can try to get at whatever part of that interaction between people that we care about as economists, all right? So models are simplified versions of reality, and they're built with assumptions, just like maps are built with assumptions. So this map has assumed that roads are red, that these roads are blue, that the water is all this color blue. It's left out some different buildings here. All maps, like all models, make assumptions, and those assumptions are false. They're not true. They don't truly represent the real world, all right? But you have to make these assumptions in order to have a model that can be useful for some reason, all right? So I struck out this phrase here that models are considered good if they predict accurately. The reason I struck it out is not because that's not true, but that's only one way in which we judge models, all right? Some models are built to predict. There might be someone who builds a model to predict the outcome of the presidential election, or builds a model to predict how the economy of California will grow. But that's only one reason that we build models. We build models for a lot of other reasons, and we're going to talk about one of those reasons in this screencast. Often what we care about really is, how do I isolate the effect of one variable, say education, on another variable, say wages, all right? And so that's not necessarily prediction, and you would build a different model. So that's why I wanted to highlight that. So how do we consider if a model is good or not? Well, we consider a model good if it's useful for the purpose it was designed for, all right? So for example, if you were to draw me a map from here to Union Square, and I took a look at it and said, this is a bad model, a bad map. I can't get to Pittsburgh using this. Well, that's not fair. That's not what you designed that map for. It's not what that model was designed to do, all right? So we judge a model by whether or not it's useful for telling us something about the real world that we care about, all right? So an important assumption that you'll see in a lot of models that economists use is something called a ceteris paribus assumption. Ceteris paribus is Latin for all other things being equal. And and what we do is we try to change one thing at a time, but hold everything else constant, all right? Remember, the world's a complicated place. Lots of things are always changing all the time. But in a model, in that controlled environment that we have built, we can say, well, what if I add one more year of education and hold everything else constant? How does that affect wages, all right? So that's why we use this assumption so often. It allows us to isolate the effect of one variable on another. We're going to come back to that ceteris paribus idea in a minute, but I need to give us a little more vocabulary here of how to talk about our models. So in a model, you have factors that are endogenous to the model, which means they're in the model, and you have factors that are exogenous. What are endogenous factors? Well, endogenous factors are variables that are controlled for inside the model, all right? So we're able to try to hold them constant while we move other variables to see how it affects the dependent variable, the thing that we care about. In a minute, I'm going to give a more concrete example that I think will be helpful to us. What are exogenous factors? Well, exogenous factors are things that are outside of the model. They're not accounted for. They're outside of our control. And so what we would hope is that once we have built a good model, that those exogenous factors, leaving them out, isn't somehow clouding the analysis that we're doing. All right, so again, I think an example will be helpful here. So let's take this example. What determines a person's wage rate? All right, well, here's just a picture model, all right? So we have their wage here on this side, and this F just means wages are a function of all of these things: education, age, experience, skills, pleasant conditions, and whether or not they're female, all right? So wage could also depend on a lot of other things, all right? So the first thing we want to think about is, how does wage depend on these endogenous variables? So if I were to hold all of these things constant and only change education, what would that do to wages? Well, we'd probably think that that would increase someone's wages, right? What about age? What if I could hold all the other things constant and only increase age? Well, we might think early on in someone's career that has a positive effect on wages, but a lot of economic studies that labor economists do show that toward the end of someone's career, it can actually have a negative effect on their wages. Experience is probably positive, skills positive. Whether or not you have pleasant working condition is often found to have a negative effect on your wages. What about being female or not? So here's an example of something that labor economists study a lot. What they try to do is say, I want to hold all these other things constant. All right, and statistically there are ways they try to do this. And I only want to look at how the only difference between people is whether they're female or male. All right, so if you have enough data, then you can try to find comparable people. This is what the statistics tries to do, sort of. All right, and so if you find that someone who in all these other ways is the same, but they're female and their wages are lower, so if there's a negative effect here, then that might be evidence of discrimination based on the fact that the person is female. All right, so that's just another way that economists try to use ceteris paribus in order to isolate effects in models. All right, again, ceteris paribus means all other things equal. All right, I just went through that. All right, so what I want to leave you with here is we need to talk about faulty assumptions, and I don't really like the way the book puts this. In my upper level classes, I do a whole section on philosophy of science and assumptions and stuff like that. But I think for our purposes, we don't need to really go down that road. But just because assumptions are false, it doesn't mean the model is useless. All right. Again, all models have assumptions that are false. That's what a model is by definition. Again, use the metaphor of maps. All maps are false in a way. All right. They all represent the real world in a way that is not true. All right. Have you ever looked at a subway map in a big city? It doesn't even hardly follow direction very well. Distance is all out of scale. It's a really bad map if you are up on the surface trying to walk around and get around the city. But if you're under the city in the subway, then it's a very useful map. All right. But we do need to understand that using the wrong map for the wrong job, all right, can be very dangerous. So an example of the faulty assumptions here is that pre-2008, lots of computer models that financial companies used and banks assumed that housing prices would always go up. And that turned out to be a really bad assumption. And so that model turned out to be really unuseful, to say the least. And so we had a crash in housing prices. All these financial models, all these financial trades that had been set up to happen, all of the planning that assumed housing prices would always go up or stay the same, it all crashed and we went into a great recession that we're really just now coming out of. So using the wrong model, there are bad models. It's not that there are no bad models. The point I want to make, though, is that just because assumptions are false doesn't mean the model is bad. And be happy to talk about that one-on-one, and we may talk about it some when we meet a little bit more. And the last thing I want to leave you with here is a clip from Zoolander. Zoolander, he's a model and he's retired, and someone is trying to entice him back into modeling. And so that's the clip where the clip starts that you're going to see. Zoolander does not like a model that he's going to see because it's false. The model is not the real world. And so you'll have to see the clip to figure it out. Just go to YouTube. In the comments, I've got the link to the YouTube video there, and you can check it out.